Okay, in the first video in the series on molecular substances, we established the idea that the forces of attraction that control the melting points, for example, and the boiling points of these substances are forces of attraction between molecules. And what I want to do in this video is address that situation more closely. All right. And the reason that I want to do this is to make sure the viewer understands the difference between the forces of attraction in molecular substances by contrast to things like metals and ionic compounds, just to name a couple of the other options that are out there. All right, and our model system focused on carbon tetrachloride and on water. And I picked these two different molecules purposely because water represents perhaps one of the more polar substances that we find on our planet, and carbon tetrachloride represents pretty well a standard compound that is nonpolar. All right, now the first thing I want to address is this idea of forces of attraction that are occurring between molecules, in contrast to forces of attraction that are happening within molecules. So first off, let's just briefly talk about forces of attraction within. All right, so if I'm talking about a force of attraction within a molecule, I'm talking about the force of attraction that exists, for example, in water between the hydrogen, this hydrogen, okay, this hydrogen here, as it is bonded to this oxygen here by this covalent bond. This is a force of attraction between two atoms within the molecule, and this force of attraction between this hydrogen and that oxygen has nothing to do with force of attraction between molecules. This is a force of attraction within the molecule. And by the same token, we can make exactly the same argument for the bond between the Cl and the carbon. All right, now this is not to say that these bonds, the carbon chloride bond and the hydrogen oxygen bond here, are not contributing to the polarity or the non-polarity of the molecule. All right, it does have something to do with that, but it's really important for the viewer to understand that we're talking about forces of attraction between molecules. All right, so let's get to that. If we think for a moment, all right, what's going on in the melting point of a substance and in the boiling point of the substance? In these regions, as I described on the heating curve video, we have the breaking of bonds that are between molecules. Between the molecules. So if we look at carbon tet and we just try to simply represent what's going on with that, we can have one molecule here. I'm going to put a circle around it. And we can have another molecule adjacent to it. Like this. Put a circle around that. The intermolecular bond that we're talking about, the intermolecular bond, or the force of attraction between the two molecules, is here. That's what this is. Force of attraction between the molecules. All right, now in the water molecule, it's a different situation somewhat. Same idea, same concept, but it's a different type of an arrangement, because remember back to the first video in this series, we talked about the fact that there's a major structure difference between this molecule, carbon tetrachloride, and water, because it has a top and a bottom. So if we look at the water molecules, remember they have opposite charges on opposite ends. And in the case of water, the water molecules can line up like this. All right, and in this case, with water, the intermolecular bonds are here, or the forces of attraction. So they exist between the hydrogen on one molecule, because remember, here's our little partial positive charges, right? And then the negative charge on the oxygen. So these little electrostatic opposite charges get lined up like this in water. So again, I want to emphasize that the forces between the molecules in both cases look like this.